All right, we're officially recording.
Microphone on.
Mic is on. Can you guys hear?
Yep, we can hear it.
Daniel, is that a yes?
Yes.
Sweet.
Okay.
So let's give Joey a big round of applause.
Hello, everyone. I'm giving a bite session talk today on things that you're not supposed to do with Ruby, and also just some cool tricks in general, I think. So I guess it's kind of like a compilation of them, not super well organized. So I'm just gonna like go through one by one, take what you want. All right. So first thing I found when scouring the internet for this was that we can access the memory behind like Ruby code. So like Ruby allows us to interact with it at like a high level and not access pointers or anything, but we can't actually get pointers with the fiddle module. And so you can actually segmentation fault in Ruby. I know that people thought that was like banished to C or whatever. Apparently it's not. So if you run that, it actually just crashes the kernel that I'm running for the Jupyter notebook. So I'm gonna have to restart it. And so next trick is there's actually keywords in Ruby called end and begin, which you can just like, you have to put this at the top level of your code. You can't put it like in a function or anything. And so it'll just run whatever is in the begin first, and whatever is in the end last, and then everything else just like in between the two. And so if we run this, oops, I think I might need to restart the kernel. Okay, cool. So we have whatever is in the begin, which happens to be last in the code, executing first, and then printing out 1, 2, 3 in the middle. And I think that the end isn't printing right here because I'm using it in like a Jupyter notebook. And so there's like other code that still needs to run. But yeah, I think if you wrote that in like a regular Ruby file, this would run after the puts 1, 2, 3. So that's just another weird thing. I hadn't ever seen that before. So okay, I had fun with this one. So in error handling in Ruby, you have like a few different options. So you can like type begin, and then I think it's like rescue, and then there's another keyword which is ensure. So if you have an exception in begin and you have a rescue keyword, it'll try and execute whatever is in the rescue block. Ensure runs no matter what. And so you can just avoid having a rescue block and then just go straight to ensure, and then recursively call the function that threw an exception. And it'll it repeatedly calls itself. And it throws like a ton of exceptions. You see a ... here. There's supposed to be way more. I think it's like 1000 squared divided by 2 as the number of lines that it's supposed to be printing here. I put is less than 1000 here to stop it from going in an infinite loop. But anyway, yeah, so there's also like, you could also just run the rest of your program from ensure, which I don't know, I feel like that would not be very fun to read as an instructor trying to follow that through. And then once the program successfully executes, seeing that there is an exception at the end, like why is it working correctly and then there's an exception randomly? So yeah, I thought that was a lot of fun, just having ensure and then calling the rest of the program. So that's recursively throwing an exception and then calling itself. So what if we could recursively make a Ruby file call itself? And so Ruby is able to run bash commands just with backticks like this. And so if you print, if you do like ls and backticks, and then dot split just to make it an array, and then you print that, it shows you like all the files that are in your current directory. These are the files in my current directory. And so I didn't want to like crash this or something, so I put it in a separate file. But it actually does go in an infinite loop calling itself. So if we type Ruby call self.rb, it's not done executing, so I'm going to stop it. And so you can see that you can like recursively call sub processes and make the program call itself. So like, I don't know, who the fuck needs recursion in our regular functions when you can just write a program that recursively calls a program? I can't see the delete thing. Okay. So yeah, I thought that was a lot of fun too. You can do a lot of things with bash commands in Ruby. Okay, so next thing I thought was funny was .toString. So this is different from .2s. .2s is like an implicit conversion to a string. So like if you interpolate a string, so like let's just make a variable real quick. So B is going to be a string, and then we can say like print B, and then we interpolate it like that. That's implicitly converting it to a string. It's calling .2s, and so that would just print B colon. I'm gonna have to put that in a separate cell. Not just prints B, ABC, interpolating it. So that's calling .2s from the hash symbol and then the curly braces. But you might have seen this error message before, no implicit conversion of integer into string. And so that's because there isn't a .toString function, this one. And so if you're like adding two things, you're going to want to make sure that they're able to actually add together. And so you're going to have like a whole separate function that's .toStr rather than .2s to make sure that you're not getting something wrong, like having weird things add together in the program. And so I created a separate file to kind of demonstrate this. So if we run this, it'll throw an error, but I'm going to comment it out. And so what you actually can do is you can use Ruby's built-in integer class, and then you can define toString for it. And then if you print that, it'll get rid of this no implicit conversion error. So if you gotta save it first and then run that. Pardon this, we'll get to that. But it prints out a +1 because now it's just it's calling .toStr. And so it's not throwing an error anymore, which means that we can do a lot of weird things with that. So I created a pizza class and it has some methods. It has .toStr, .toS, and then .toInt. And so each of these are going to return different things. And .coerce is just needed for this. We'll talk about that in a bit. And so depending on the context, you can make it return very different things. And so if you just like, if you have a string and then you want to add a pizza object to it, it's going to call the pizza object .toStr. I have them over here because it's a little confusing. And so that was pizza right here. And so that's printing, this is a pizza, which is down here. But then if you interpolate it, it's calling .2s. And so that gets a different value. That gets the 3 right here. And so you'll see that pizza taste as string is 3. And then you can also call it in like an integer context right here. So that's what this %i means. It means that it's taking this thing and it's trying to turn it into an integer and put it in there. And so this actually calls the pizza object's coerce method. That's also like a special method in Ruby, which then converts itself to an integer and converts the next thing, which is, actually, I'm confused. It might be calling .2 int directly here because it's just %i, I'm not super sure. But regardless, eventually it'll call the to int right here, because if it's forced, it'll call it anyway. And so you can get another value in a different context from that, all without like actually calling a function on it. It just depends on the context, whether you're like concatenating it, interpolating it, or like using, I don't know if that's called like an escape character kind of, but for string interpolation. So it'll call .to str, to s, or to int. And I don't know that there's some fun things you could do with that to drive someone insane, like make it off by one number and make them like wonder like why is this off by one? Until they eventually find that in the class. And
That's
so
cruel.
it is cruel. Things you're not supposed to do with Ruby, right? And so I created like a subclass of this, and so you can see like it'll just call to int and it'll get 10 this time. Thought I would start a flame war during my back session. And then you can also you can use multiplication automatically with objects. You can like override that in Ruby classes. So like right here, this is the method name. So if you call pizza.new. Or if you call just like the asterisk symbol on a pizza object, it'll call this. And then value is like the next object in the chain. So value is going to be this. And so it coerces itself into never mind. It's coercing the pineapple pizza into an integer. And then .inject, that just means like it's putting an asterisk symbol between a list. Like say we have a list like this, the .inject is making it just go like 10 times 10. And so if you had like another one in there, that would be going to 10 times 10 times 10. That's another useful trick if you ever need inject. But yeah, so you can also apparently multiply objects like that from their to ints. So that was all for that file. I'll not bother with that right now. Okay, back to the original Jupyter notebook. Let's fix that. That was for that. So then this I also thought was weird. You can use like a range from true to false. So like normally you'd use a range like 1 to 10, 1.10. But it actually works with booleans. And so you can do print the index. So that's just saying like for each number from 1 to 10, print it if that number is equal to 4 dot dot is equal to 6. And so let's see, if I is 3, it's not equal to 4 and it's not equal to 6. So that's going to be false dot dot false, which evaluates to false, so it doesn't print it. If I is 4, that's true, and it's not 6, which is false, so it's true dot dot false, which apparently evaluates to true because it prints it. But then it says print it if it's 5, it's not 4 and it's not 6. So I don't even know like why that would print 5 there. Actually, I'm confused. I'm just now realizing that. But then it also prints 6, and once it gets to 7, it's just out of there. It's a little weird to me. But okay, anyway. So if I lose the evaluation, might come later. I think I forgot to edit that. But if you do true dot dot false, if you just print that, it gives you an error. But then if you do true dot dot false and then do exclamation point twice, which like converts it to a boolean and then back, apparently that works. So what this is saying is like we have a range from true to false. I think it's because that stays in a range, but then when you call not that, like you call the opposite of it, then it coerces it into a Boolean, which is going to be false, and then we call the not again, which converts it to true. I think that's like really weird that you can use not on it twice to do that. The same goes with like Neil. So Neil is like Ruby's null for anyone who doesn't know. And so it'll convert the Neil to true, and then it'll convert it back to false. And so the double exclamation point is like a way of converting objects into Booleans, and apparently it works with a range from a Boolean to a Boolean, which I think is really weird. So yeah, that true ... false evaluates to true, but false ... true evaluates to false, apparently. Don't know why. Next thing is we can actually use keywords in Ruby as parameter names. So we have a function right here, foo. I'm pretty sure I just took this like directly off of a website, so that's why it's called foo. I have those sources down below, I promise. So define foo, and then we have if, which is a keyword. You normally can't really use that as a variable name. But then you can call binding.local variable get and pass it in as a symbol, and apparently that works. So if you just call foo, which is literally in the parameter name, that's gonna throw an error. But you can call binding.local variable get, and that does not throw an error for whatever reason. And so then we can call foo if, and then put it as false, and it prints false, or like true, or whatever you want it to be. So yeah, using Ruby keyword or reserved words and parameters of a function. Okay, so Ruby lambdas, for people who don't know what lambdas are, is kind of like you're saving a function in a variable. And so you can just define it in one line. I should probably show like what Ruby lambdas look like. So you could say my lambda equals, and then the notation for it is you have like an arrow like that, and then whatever code you want. So like print hi, and then we can say my lambda dot call, and that prints hi right here. So I thought it was kind of funny in the Jupyter notebook. The first time you call this thing, it won't run. The second time you call it, it also won't run. But then the third time you call it, it works. And so really what's going on there is it's like saving variables and then updating them in the background. Like every time it runs, it updates it, because like when you run this cell, the previous objects persist. I just thought it was funny that like after 3 times it decides to work all of a sudden. So yeah. And then I also just wanted to say, like, what the fuck is this notation? I don't know who chose like 3 equal signs for this, or like dot brackets. But this is valid Ruby. So this is just calling, these are different ways to call a lambda. So you can use like the dot equals equals equals, dot square brackets, and dot call. And I was having some fun, and so I decided to call the lambda on the lambda on the lambda, and then call it on assigning the lambda to itself, but where the argument name or the parameter name was also the name of the lambda, and returning itself. If you want to like confuse the fuck out of your professors, that's probably one way to do it. Oh yeah, it also just works every time after the 3rd time. So yeah, so what's happening here is it creates a lambda function, and then there are 3 different ways to call it: the equals equals equals, brackets, and call. And then this is the last line is just an explanation for what's going on. So it has a equals hello, and then it returns that. I think what's going on here is also that it's like defining a as a function that returns whatever it's passed in. So it returns the hello, and then the function that's taking that in just returns it. And so it like passes it on recursively to the last last proc. Oh, also to clear it up, there is no like actual lambda in Ruby. It's more of like a notation. What this is actually called is a proc. But whenever you use the arrow symbol like this, you're gonna call it like a lambda. But it's actually like the class is just called proc. And so it's like an anonymous function. Okay, next thing is you can actually use infinite indexing on things. So this is valid Ruby code. Can print out what it's doing. So we're defining a list of numbers 1, 2, and 3. And so you can call 0 on that list. And so that gets 1, but then you can also call an index on an integer, and it just grabs the first digit in that integer. And so calling 1, 0 actually just returns 1. And so it turns out you can just do that as many times as you want. And so what happens here is it grabs the first item in this list, and then it grabs the first digit in the integer from that. And so that's why you get print 1 here. And then kind of same thing goes for strings rather than integers. It just gets like the first letter in it. And then you can also just call brackets on a single letter and it just returns the letter. So it's kind of, for this one, you have a string and you call brackets and it gives you a character, but in Ruby, they're the same thing. And so you can call it again. And then with an integer, it just gets whatever digit it is. So yeah, so another thing you can do in Ruby that's kind of weird is you can use statements in class definitions, like not in methods or anything. And so at the start of like at execution time, this is actually just going to print out howdy hey there and howdy avianto. I'm sorry for anyone who actually speaks French. And so just like the first time you run this, it will print that out and it's in a class definition. So that's, I don't know, it feels like pretty bad practice to me to have that there. So you could just have like, I don't know, an initialize function. And that also works. So yeah, okay. And the last thing you're not supposed to do that I had on here is undefining built-in classes. So Ruby has the undef keyword. And so you can call that on a class and it actually, it gets rid of it. You can't use it anymore. So I wasn't quite sure what was going on here because if you only have one undef, it still works. So I think that it like removes the array method from like a separate class, but then you can still call array.new. But then when you try to undefine the method from a separate class again, it throws an error. I'm not entirely sure. I would have to look into that more. If anybody knows, let me know. But yeah, so that you can just undefine those things and yep. So okay, now for like useful or things that I thought could be useful in certain situations. Number one is the dot methods function. I had never heard of it before, but it actually just gives you a list of methods on your current object. Seriously. And so you can look through it and see if there's what you want in it. Or also just like explore things like, I don't know, what is there in here? Oh, I guess there's the instance variable get thing that we were talking about earlier with the using keywords, define singleton method. So it's probably for like making class like static methods. I don't know if these are, but yeah. So I thought that was super useful. Also, for anyone who doesn't know, you can like open up like Ruby in your terminal with IRB. So like I have my terminal right here. I can just type in IRB and now we can just type in whatever code we want. That's pretty useful if you don't want to like create a whole file to run a program. So yeah. using this typing code there. I also put in here, there's ones for Python and JavaScript too. Python is Python or Python 3, depending on your like terminal, I think, or like installations. And then for JavaScript, I think it's Node. I didn't actually run that. Daniel might be mad at me if that's wrong. Sorry, Daniel. I'm kidding, he's too nice. And then I found this online. Apparently you can like create your own interactive Ruby shell just with this short command. I thought that was pretty cool. So if we open this up and type that in, so now if we like type that, it just prints out whatever it is, and then shows you the return value. So I don't know if for whatever reason you don't want to use IRB, you can use this instead. But yeah, so that's another trick. So for useful like type coercions in Ruby, earlier I was just thinking like we can remember it as a fish because there's .to array, .to float, .to integer, .to string, .to hash, and that's a way to remember it. And so you can just call these on objects and it'll convert them into whatever type you want. So if we have like an array right here and we want a set instead, we can just call .to set on it. If we want to convert a string to a symbol, it doesn't work with integers, I found out, so I had to change that to a string. It'll do that, it'll convert it to a symbol. Same with to array, it can convert a hash to an array of arrays of 2 values, which are the key and the value. And then you can also convert it back with an array of arrays of 2 values. You can convert it to a hash. So that goes to a hash with like A goes to 2, B goes to 3. So those are some useful functions. There's also 2R on here. I hadn't heard of that before. But that converts it to like a fraction from a decimal. I'm not quite sure when I would use that personally, but it's out there. And then yeah, there's a 2str that we were talking about earlier. So and then okay, so next thing is for arrays. We have map, filter, and reduce in Ruby. Which is just map is, I have this function and I want to perform this function on every item in an array. And so that can be pretty useful. So if we have like an array from 1 to 10, and we want to square it, we can just call .map on that. And then this is the notation for it. So each item in the array is going to be stored in number. And then we're going to have whatever expression we want with that here, which we're squaring it. So say like 1 goes into number, and then we return 1 times 1, which is 1. And then 2 goes into there, which returns 4. And so you can see like it returns that. There's also filter. So if we store like the squared numbers in this variable, we can just keep all the ones that are less than 30 by using .filter, and then it's the same notation, just we have a Boolean expression here, and if it's true, then we keep the number. If it's not true, then we get rid of it. So if the number is less than 30, if that's true, then we keep it. So you can see that here. And then there's also, so that's filter, and then there's reduce, which kind of combines all the numbers in a list in a certain way, depending on what expression you have. So this 1 right here, this just means that we're starting at 1. And then that's stored in mult. It's just use that short for multiply. And then we have our numbers and the array go here. And so it's going to go through 1 by 1 and say, okay, what's our current mult? It's 1. What's our current number? It's 1. So multiplying that, it's still 1, and then that goes back into mult. And then what's our next number? It's 4. So then 1 times 4 is 4. That goes back into mult times 9, yada yada, and then it arrives at that. So that can be another useful tool if you need to, like, I don't know, perform some operation on like a list of numbers in sequence. So next thing was we can when we use a range, it's lazy. It only like actually creates the numbers when we want it to. So we can like create a range from 1 to infinity. That doesn't take forever to build. And then you can just call dot first however many you want, and it takes the first numbers in that range. So like I called 10 right here, and so that grabbed the first 10 numbers. And then I just said raise that number to its own power. So like 1 to the 1, 2 to the 2, 3 to the 3, 4 to the 4, yada yada. So that's another trick you can use. Just have a range and then dot first, whatever. Another thing is you can pass functions as arguments into map. And so this like allows you to have your code be a lot more dynamic and flexible. So say we have like a square function right here. We can call that in map by converting it to a method with this, and then this ampersand symbol converts it to a proc, which is what we were talking about earlier. And so with map, if you pass in a proc, it automatically just passes your items into it. So like if you have a list of 1, 2, 3, it'll pass the 1 into whatever function it is, and in this case square it, then pass the 2 and then pass the 3 in. What did I do there? Oh, I didn't print them. So what is it? Okay, so first it prints the squaring of it, which is integers, and then it prints .2s. I think you pass in the symbol for 2s right here without a method thing because it's already a proc. I think 2s is a built-in Ruby function or proc or whatever. But yeah, I'm not super sure. I haven't looked into it that much. But yeah, so you can just pass in whatever function it is that has like one argument, and it'll apply that to every single value in the range. So this is just kind of demonstrating that you could create some more functions. So we have square, cube, and double, and then we're doing dot map on those symbols, and then we're using each of those symbols and mapping that on a range from 1 to 10. And so if we do that, we'll get an array of arrays where we have first the squares of them, which is right here, and then the cube of them, which is right here, and then doubling them, which is right here. Another function is dot each with index. And so this takes like an array. I think it might work with a range, I'm not super sure. And so you can just iterate through them with whatever item it is in the list, and then an index associated with it. So if you run that, it'll just say like item 0, index 0, defined right here, item 0, item 1, item 2. And then it has the corresponding index. This nil right here, don't worry about it. That was just to suppress the output, because otherwise it has like this right here, and I didn't want that. But I didn't realize I'd be going on a full screen for some reason, and so that was still visible. I didn't push it out far enough. Okay, next thing we can use is the double splat operator. And so what this does is it says you can pass in however many key value pairs into this function as you want, and it'll just put all that into a dictionary. And so we'll get to this. So right here, we're passing in like some key value pairs, and that this 5 goes to padding length, and then all these key value pairs go to splat items. And so then it says for each key value pair that we entered, print the key and then just have some padding on it. That's all that this means. And then also print the value. So if we print that, it just prints the key and the value for each of the things that we passed in. So .l just right here, that is a way to format strings in Ruby. And so we pass in however much padding we want. So I said 5, and so there's 5 spaces right here. So if we have like, well, there's 4 spaces. If we have like a string of like length 1, it'll just put that there and then it'll have 4 spaces following it. If we have a string of length 5, it'll have 0 spaces following it. So yeah, that's what the .l just does. It's a way to format strings.
I wonder if that goes to like line justify or something, if that's why it's called L just.
Yeah, that's a good question.
I think it's left.
Left, yeah, maybe
Left
like
justify?
left adjust or something.
Yes, you can do left. center.
Yeah, there's .rjust too.
That makes sense.
Yeah, so probably like adjust with that. Does anybody else have a different? Okay. So yeah, that's what that does. That's a way to format it. So aside from the confusing syntax, this is just saying print the key and print the value for each item we enter, key value pair we enter, with that much padding. So that's the double spot operator. So that takes in like key value pairs. So we can also use the single spot operator, which is not key value pairs. This is just items and it puts it into a list. So I created a function called take in list, and it has this splat operator. And so it says, okay, you pass me in however many items, I'm going to put it into a list and call that list, we're calling that list items. And then we can say for each item in that list, just print it. So you can see that it prints that. This is just returning a value, which is why I had the nil thing. So yeah, there's that too. Another thing, I thought this was really interesting, is there's a way to use memoization in Ruby. For people who don't know what that is, that's just like calling a function on a value and then storing the result of that. So you don't have to call it and like recompute that again. And so there's a really nice way to do that in Ruby, apparently, which is we can just create a new hash and then what's accumulator? Oh, I think accumulator is going to be the hash itself, question mark. And then the index is just going to be whatever value we want from it. So like we're creating this hash named fib, and so we're going to call fib of whatever index it is. Fib stands for Fibonacci for anyone who wasn't familiar. And so this is just like a way to compute Fibonacci numbers. And then .update at the end here is saying, okay, but start with fib of 0 is 0 and fib of 1 is 1. And then if the index is anything else, then you can call accumulator index equals yada yada. And so if we call that, it'll give you the numbers, much more efficient than the naive approach to calculating Fibonacci numbers. So yeah, that's a way to do memoization in Ruby. I would have to look over that many times to remember the syntax. I don't know about y'all. But, okay, cool. So next section is like string formatting. So for anyone who didn't know, this is how you can use string interpolation in Ruby. This is like the idiomatic way, the most common way that people kind of want you to use. And so you can use like double quotes, which is a string. So you can like put whatever you want in here. And then we have a float. And so we put it in here and it automatically turns into a string. So we can print that. So we have whatever we had before. And then we're converting this into that. So it just prints it all as one string. Another thing is with floats, we sometimes will want like a fixed float length. We don't want like, I don't know, one number to like print like 8 decimals and another to print 2. And so we can just specify, this is the notation for that. So this is a different way to interpolate in Ruby, not the idiomatic way. But say we have like a float right here and we only want to print 3 decimals on it. And we can say print and then %.3f. And then we have this % symbol right here, which says plug this into here, into this % thing right here. And so if we run that, it'll print 3 digits there because we have 3, it'll print 7 there. And it actually adds zeros onto the end if you don't have that many digits. So that's kind of nice to keep it consistent if some numbers have more digits than others. And then we can also use it like with a list of values. And here we're just saying like print one with 7 decimals and print one with 5. So yeah, that's how it works with a list of numbers. Another thing with strings is using printing like an integer, but in hex format. So for anybody who's like in intro to computer networks, is there anybody here who's, I don't actually know, but you can just print it. So this is saying, this is a base 16 number system. So this 3 right here, like this next digit over is actually like, it has 16 values. So in base 10, this would have 30. In base 16, it would be 48, because 3 times 16 is 48. And so using the X, that stands for hex, and so you can print it like that. You can also use like an octal based system with O. So if you print that, this is 1, 2, 3, 4, 5. This is in decimal. This is in octal version of it. Here we go to the LJust and RJust. It's just a way to format strings. So if you have LJust, it puts it all the way to the left, probably means adjust. And then if we have RJust, it puts it all the way to the right of that 10 space or 10 character long zone. So yeah, that can be pretty useful for keeping consistent formatting if you need to like print a list of numbers. So here's totally unrelated. Here is like how you can use a GET request in Ruby. So I haven't used these libraries myself. Honestly, I just pulled this off the internet, so don't ask me any in-depth questions. But we can import the URI gem and the net/HTTP gem, and apparently create a URI object and an HTTP object from that URI object. And then, yeah, the res is the HTTP response object thing. So we can print the body if it's a success. That's just like an error handling thing. So if this isn't a success, we don't want it to throw an error. So we're using the if there. It's probably going to be a success. And so we can see that from HTTPS for google.com, I was able to pull this from that. So, oops, I accidentally created extra item here. So yeah, that's how to use GET requests in Ruby. There's also a lot of other libraries I saw for it. So don't think this is your only option if you want other functions for whatever reason. I don't know what all it has to offer. So that's for GET requests. So I thought this was interesting. Ruby has a really nice way to also like store objects in files. And so if you have like, I don't know, if you have a pizza object that has a taste value of 5, and for some reason you want to store that information between running your programs, you can use Marshall to do that, and then write it to a file. So what Marshall does is it takes your Ruby object and it puts it in a binary format. And then you can like plug that, you can just use that binary to write that into a file. So I have a separate file here for that. So we have a class named soon to be binary object. I had to put this here so that it would have something to actually write to the file. So I guess just kind of ignore that, but we can create a new object here, and then we can open a file called object. And then this is just saying write our dump of the object. So this is how you like put the object into binary format. You call marshall.dump on it, and then it's just writing that to whatever file we were saying. And I think this might mean like write binary. I'm not super sure. But yeah, so we're writing it, we're opening a file and then writing that to it. And then we can also say we can load it back. So this stores it, this line stores it, and then we can say marshall.load and then file.binary read of whatever file it is. And so this reads the file and then this converts it from binary back into like an object that Ruby can use. So if we run that, we currently don't have a file named obj right now, but if you run ruby marshalling.rd, it creates the file that it's not human readable, I think, for those parts. But yeah, it stores it and then we can load it back up. And then as you can see here, we can print it. And so we have this soon to be binary object that we created. So that's another useful tool, I think. How am I doing on time?
I'm a little bit over,
Oh, okay.
but great stuff.
Okay, okay.
It looks like you're getting close to the end now. You want to keep going.
Yeah, we're pretty close. Is there like a hard limit on it or? Okay, cool. So next is 2S and 2I for anyone who's in architecture and assembly or intro to computer networks. We were using like conversions a lot between like binary and decimal and hex and whatnot. Ruby has stuff like that built in. So if you say 4.2s base 2, that'll convert it to like a string of the number 4 in binary. So it'll be 100, as you can see right here. And then same with 8, just 1000. You can do the same thing for other bases. And so this will convert 256 to hex, which is 16. And you can see that that's 100 right here. And then you can do base 15 for 256, which is 121. And then you can also do from strings back into integers. I was trying it out and apparently 36 is the highest for .2i. I'm not really sure why. Maybe there's like some type of alphabet thing for it. Oh, I bet it's yeah. So 26 letters in the alphabet plus 10 decimals. Thank you, Griffin. So that's why that's the max apparently. But it converts it. It says, okay, we have this number and we're saying that this number is already in this base. Convert it back to decimal. And so that's where you get the 1296. So if we like, I bet if we do 129 print 1296.2s. So we're starting 2s starts in decimal and we're converting it to some other base. So if we do 36, that should go back to 100, which it is. Okay, cool. So it takes like right here, it says, okay, it's already in whatever base we're specifying, convert it to an integer, and which is displayed in decimal. So yeah, that's the last thing I had for y'all. And here are my sources. I posted a link in the Discord chat for events, like the events channel, to the GitHub for it. This is in like .ipynb format, so it might not be very accessible for people who don't have Jupyter Notebook. But I don't know, if you are so inclined, you could like install that. There's also like these files in it, so you could check that out too without Jupyter Notebook. But yeah, so that was my bite session. Hopefully how to drive your professors nuts a little bit, but also some cool tips in Ruby or cool tricks. So
That's awesome.
Any questions, comments? I don't know.
I just wanted to say that, like, you know, the first app,
Yeah.
it's like you run into these problems when you start a new language, and like I like the way that you look at it, like it's kind of fun to like run into those problems.
Yeah.
I like that approach. I want to say that.
Recursion is also fun to be super into personally, but yeah, thank you.
We got one more question in the back.
Oh, sorry, what's up, Eric?
Are you gonna post this anywhere?
Yeah, so it's on my GitHub, which I linked in the events channel in our in the Cascades Tech Club Discord server. Yeah, you will need Jupyter Notebook to open the main file. But yeah,
And Jupyter Notebook is available for free?
Yes.
Through Google, I believe.
You can also use a Google Colab for this.
oh, sweet.
Google Colab.
That's awesome. Then accessible to everyone.
Yeah.
Yeah, sorry, everyone with VS Code. As like a VS Code user, I just assume that nobody uses anything else.
And yeah, I
What was
think,
that? Yeah.
all right,
Oh,
guys,
yeah.
we're gonna close
Yeah.
the recording. Thanks for hanging out with us.
All right.